Good morning, everybody. This is Miss Pollock, and I hope it is sunny where you are. It's not sunny where I am, but I know it's sunny somewhere. So today we're going to talk about something called the Mulvey Method, which a student of Mr. Lerner's kind of came up with one year, and he found it to be very useful. It's a way to compare different quantities when a change is made to a variable in an equation. Like if we know the kinetic energy equation is 1/2 m times the velocity squared. So if I change the mass or I change the velocity, we could find out what happened to the kinetic energy. Or if I change the kinetic energy, we could find out what would have happened to the mass or the velocity. So it's a useful method, and I'm going to show you how to do that. So the first question is, what happens to kinetic energy when the mass is doubled? Well, I'm going to show you the whole process here, and as you get better, I'm sure you'll be able to streamline it, but I'm going to show you the whole process. So first I write the old and the new, and I write my equation for kinetic energy. And kinetic energy is 1/2 mass times the velocity squared. Well, it's easiest to compare things to 1. So if my kinetic energy is just the way it is, right, then that means my kinetic energy, I'm just going to put 1 in for everything. 1 in for 1/2, 1 in for mass, and 1 in for velocity. So my kinetic energy is 1. That's the norm. That's what I'm comparing things to. Now I'm going to double my mass. So what would my kinetic energy be? Well, 1/2 has not changed. It's still 1. I've changed the mass. It has now doubled, and my velocity has changed the same. So now my kinetic energy is 2 times the amount that it was because I doubled the mass. Okay? Guys, kind of see how this works? So let's do another one. All right. What happens to kinetic energy when the velocity is doubled? So again, I'm going to write down the equation for kinetic energy. My cat is right here bothering me. All right, so again, my original state for my kinetic energy is always going to be 1. I'm going to put 1 in for everything. So my kinetic energy is 1. What if I doubled my velocity? Well, this is my new velocity my new kinetic energy when I double my velocity. The 1/2 stays the same, the mass stays the same, but now I double my velocity. So my kinetic energy is now 4 times the amount of the old kinetic energy. So my old kinetic energy was 1. My new kinetic energy is 4 times the amount. So by doubling the velocity, I quadruple my kinetic energy. All right. So here, this one is a little bit more difficult, not as easy to see, but you can see the power of the Mulvey method in this case. So what happens to the length of a pendulum when the period is doubled? So we know that the period of the pendulum, 2 pi times the square root of L over G. So I'm going to write the equation for my old and my new. All right, so my period is 1. 2 pi stays the same times the square root of L over 1. All right, so we can see that 1 equals the square root of L. So 1 equals L. So I'm comparing what would happen now if I doubled the period. So I put in 2 because I've doubled the period and everything else stays the same. I want to find my new length. So when I do the algebra, I can see that 2 equals the square root of L. So 4 equals L. So L is quadrupled when the period is doubled. All right, a way to compare different things when changes are made to different quantities. Have a great day. Hope you get some sunshine.